Alright, in this section we are going to be working higher order derivatives. That's what we're going to be talking about. So if you know how to take a derivative, well, then you'll know how to do this. Anyway, so let's just get started with an example. Let's say that we have h of x is equal to, and of course I'm going to start off with something easy, like h of x is equal to 5x. And we want to find, well, we've been finding h prime of x. We've done that already. And that's the first derivative. But let's say we want to find the second derivative. So this would be h double prime of x. So that's the second derivative. Well, let's just find the second derivative. So if we were asked to find h double prime of x, the first thing we're going to have to do is we got to find h prime of x. Well, you should know that taking the derivative of 5x is just 5, right? And then h double prime of x is, you guessed it, we're going to take the derivative of the derivative, and that is just 0. Okay? So simple enough. Let's work another example. Let's say that we're given m. Yeah, I'll use some different stuff here. Call our function m. We got m sub t, or I should say m of t, is equal to 10t squared, and we want to find the second derivative of m. So the first thing we got to do is find the first derivative, and that's going to be 10 times 2 is 20t. So that's the first derivative, and then we got to find the second derivative, because that was our goal, was to find the second derivative. And of course the second derivative is just equal to 20. So hopefully by now you're getting the hang of this. Alright, we'll call our function this time, how about g of s, or t? I think I wrote down s in my notes, but we'll keep t here. T to the fourth plus 30, or plus 3t squared minus 10, and this time we're going to be asked to find g triple prime of t. And so what is this? This is find the third derivative of g. So here we go. Well, in order to do that, we've got to find the first derivative, and that's going to be 4t to the third plus 6t, and then of course the derivative of 10 is 0. Now we're going to find g double prime of t, and that's going to be 12t squared plus 6, and now we're going to find the third derivative of t, the third derivative of g with respect to t. We got 2 times 12 is 24t. So there you go. So that's the third derivative of g here, of g of t. Alright, now what happens if they were asked to find the sixth derivative or the fourth derivative? Well, we wouldn't just keep writing prime, prime, and prime and just keep on going on with that. We got some different notation for that. So let's say that we were asked to find, we'll go back to our notation, f of x. We got 2x to the sixth plus 10x minus 1. And we are asked to find f of 4, the fourth derivative. So instead of writing prime, 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 we just put a number 4 up here and we put a parentheses around it. I don't know. I put a parentheses around it. And then, okay. So we're asked to find the fourth derivative, but of course So we want to take the fourth derivative. Okay, so we're going to say f prime of x is equal to 2 times 6 is 12, x to the fifth plus 10. So that's the first derivative. The second derivative is going to be 60x to the fourth. I think I'll just write it the next one here. The third derivative of x, okay, is going to be 240 x to the third, and then our fourth derivative, and I'm just going to write it up here. Okay, that's supposed to be a 4 right there. It looks kind of like a 9, but it's supposed to be a 4. Okay, so the fourth derivative, we're going to take the derivative of this guy right here. And, let's see, 20, 12. Trying to do that math in my head here. Okay, I believe that's going to be 720x squared. Okay, so that would be the fourth derivative. Alright, moving right along. So hopefully you're getting the hang of these derivatives when they say higher order derivative. Now there is a reason why we need to at least find the second derivative in the applications under finding the concavity. Remember, the first derivative we used to find critical numbers with and find if our function's increasing or decreasing. I don't know if you've already done that yet or not. I can't remember. Okay, anyway, let's say we have f of x is equal to 10x cubed minus 10, and we are asked to find, that's right, the fifth derivative. Okay, well, the power only goes to 3. So if you started taking the derivative, you remember you subtract 1 from the power every time you take the derivative. So if you took the derivative, took the derivative, took the derivative, we should end up getting down to 0 there, but I don't know. Let's just do it real quick. F prime of x is equal to 30x squared. F double prime of x is equal to 60x, and the third derivative is going to be 60, and then the fourth derivative is going to be equal to 0, and then for some who knows what reason in the universe, you need to take the fifth derivative, right? The derivative of 0 is 0. Okay, so there you go. So you see this on a test, you know, it's kind of like, oh well, this is going to be 0. I mean, you subtract 1 every time you take the derivative. We got to 0 on the fourth derivative here. So if this is a 3 and we're going to 4, you know it's going to be 0, right? So just add 1 to this exponent right here and you'll know that it'll be 0. Okay, you see the pattern? Alright. Yeah. Oh, let's see here. Let's work a little bit more difficult one. We got to use some rules. We're going to do one where you got to use the product rule here. So we have x. So I guess this is kind of a little refresher here of taking derivatives, huh? Alright, and we are asked to find, we want to find the third derivative. Now instead of writing prime, 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 I'm just going to write a 3 up here. The third derivative of x. Alright, we don't normally write it. We don't write 1s or 2s, but I guess we could write a 3. Third derivative. So we're going to take the first derivative, right, using the product rule. So the derivative of x is 1. And of course, we just rewrite everything. Rewrite that second function, plus rewriting the x. I'm going to go ahead and take this 3. We're taking the derivative of this piece here. Take the 3, bring it out front. Rewrite what's in parentheses. Subtracting 1 from the exponent, so that becomes a 2. And of course, you take the derivative of what's in parentheses, but the derivative of what's in parentheses is just 1. Alright, now let's take the second derivative. So this is going to be h double prime of x is equal to, so I'm going to take the derivative of the first one here, so bring the 3 out front. We have x plus 1 and subtracting 1 from the exponent, and you get a 2 there. Okay, that's supposed to be a 2. And of course you take the derivative of the inside of the parentheses and bring it out, but the derivative of x plus 1 is just 1, so we don't need to write anything. Now in this one here we're going to have to use the product rule again. So I'm going to take the derivative of 3x, and derivative of 3x is just 3. And then of course rewriting the x plus 1, right, squared. Now I'm going to take the derivative of the x plus 1 quantity squared. So that means I'm going to take this 2, bring it out front, and 2 times 3 is 6. And of course I rewrite the x, rewriting everything in parentheses, and subtracting 1 from the exponent, so we're not going to just write a 1 there. We won't write anything at all, right? Okay, let's look at this. Well, we can condense this down before we take the derivative again, so let's just go ahead and do that. All right. Okay, so we have, so these are both like. So we're going to have 6 x plus 1, right, quantity squared. Okay, these are both like terms, so we just add their coefficients, and then plus, and you know what, I'm going to distribute this 6x across. So we have 6x squared plus 6x. Let's do that. Now we're looking to find the third derivative. And instead of putting 3 primes, I'm just going to put a 3 here. Alright, and I don't know, put a parentheses around it. Okay, so take the 2, bring it out front. 6 times 2 is 12. Rewrite x plus 1, subtracting 1 from the exponent, and of course take the derivative of the inside, bring it out, it's just 1, right? Plus, and so the derivative of 6x squared is going to be 12x, and the derivative of 6x is just going to be 6. So now what I'm going to do is I'm going to go ahead and just simplify this down a little bit more. So, right, the third derivative of h is, distribute this 12 across, we have 12x plus 12 plus 12x plus 6, and that's going to all simplify down to 24x plus 18. So that's our third derivative, finally, of h, 24x plus 8. Man, it's crazy. Alright, let's see if I can work in another problem here. I don't know. Okay, what do we got? We've got y is equal to x over x plus 1. Now I'm going to do some different notation. Well, dy over dx, you should have seen that by now. Some of my other problems I use different notation, is the first derivative. But if I said we need to find d2y over, I guess you'd say dx squared there. This is the notation for the second derivative, just using different notation here. But this says, okay, we want to find d2y over dx squared. Then this right here is going to be the second derivative, right? We want to find the second derivative. We are, okay, let's just get started. So, gone over the notation there. So the first thing I want to do is take the first derivative. That is, I want to find y prime, or in this case, I'm going to actually, instead of writing y prime, I'm going to write dy over dx. And that means that we have to take the derivative, we're going to use the quotient rule. So we take the derivative of the numerator, and the derivative of x is 1, times the denominator, minus the numerator times the derivative of the denominator, and that's just 1. And of course that is all over x plus 1 squared, right? So we square the denominator. That's the good old quotient rule. Now what I'm going to do is clean this up a little bit, make life a little easier on us. So we have dy over dx is equal to, so this is x plus 1 minus x times, okay, let's see, can we do this in our head? This becomes x minus x, and x minus x is, you know what, let me just write it over here. This is x plus 1 minus x. Maybe you'll see it a little better if I just rewrite it. So as you can see, these x's here are going to cancel out. Okay, so the x's cancel out and we're left with 1 over x plus 2 quantity squared. Since I just have a 1 in the numerator, I would normally just do the quotient rule here, but let me show you something maybe I hadn't shown in some of my other previous videos, that I can go ahead and take this into the numerator, but make sure I write a -2 for the exponent. The exponent's positive, we take it into the numerator, and it becomes negative. Alright, now I'm going to go ahead and take the derivative again, the derivative of the derivative. So that's dy, this is going to be d2 dx. Alright, so we don't write a 1 here, right? And that's, okay, so there's nothing here, but pretend there's a 1 there. Alright, so I'm going to use the, well, it's like the chain rule, but the general power rule here. Take the -2, bring it out front. Subtracting 1 from the exponent, so that becomes a -3. And of course you take the derivative and bring it out, but the derivative of x plus 2 is just 1. So we just leave it like it is. Right. Now I'm going to go ahead and write this with positive exponents. So the second derivative. And now there is good reasons why we have to find the second derivative, because in the section on concavity, it's pretty much necessary to find the second derivative. Alright, so there it is with positive exponents. Okay, that was fun. I think we should work another one. In fact, I could work lots of them. What else is on the list here? I think I've got a bunch of examples lined up. Oh, this is not going to be a nice one here. This is going to be a challenge. Take several minutes on this problem. We got y is equal to 3x squared over x minus 1 quantity cubed. Okay, and this is what we're asking. So maybe you could pause the video and see if you can work this one out on your own. It's going to take a few minutes to work out, I promise. Alright, well, let's just get started. So dy, so we're going to be taking the first derivative, and I'm going to write dy over dx. So we're going to use the quotient rule here. We take the derivative of the numerator, and that's going to give us 6x times the denominator, x minus 1 cubed, minus, rewriting the numerator, 3x squared times the derivative of the denominator. So this is going to end up taking this 3, bringing it out front, rewriting everything in parentheses, subtracting 1 from the exponent, and that gives us a 2. And of course it's all over x minus 1 quantity cubed. Alright, so what we need to do now is go ahead and do quite a bit here. We need to try to clean this up as much as we can and do some factoring. I'm going to have to go ahead and just rewrite this. 6x x minus 1 cubed minus 9x squared x minus 1 quantity squared, and remember that is all over x minus 1, and something's fishy here. I forgot to square this piece right here. Square that, and of course you multiply exponents, and so that becomes to the 6th. And of course this is dy over dx. Now what I'm going to do, which I haven't really done much in previous videos, and you do a lot of in calculus, and that is we're going to factor this thing as much as we can, and I'm going to pull out, let's see, that we have an x squared, we got an x minus 1, yada yada yada. Okay, this is something you got to really get down. You got to get this part down. We have a 3. This is the largest number that goes into 6, and a 3 is the largest number that goes into 9, both 6 and 9. So I'm going to pull out a 3. I'm pulling out an x, and also an x minus 1. And we always look at the one with the smallest exponent, so we can pull out 2, an x minus 1 squared out of there. Now, if I pulled a 3 out of here, we'd be left with 2. Of course, we pulled out this x. I pulled out 2 of these x minus 1, so that leaves us with 1, x minus 1. And that's going to be a minus. We pulled 3 out, so that's going to be a 3 there. And left with just an x. Okay, I hope you was able to keep up with all that. And then of course remember this was all over x minus 1 raised to the 6th power. This is a big part of calculus, and that is algebra. Unfortunately, that's just the way things are. Alright, I'm going to go ahead and do some canceling here. We've got an x minus 1 squared in the top. We have 6 of them down in the bottom. So I'm going to be able to cancel this out up here and then subtract the 2 of them from this down here. So that's going to leave us with 3x. I'm going to distribute this 2 across. We have 2x minus 2 minus 3x. Yeah, you get your algebra down once you get through calculus class. That's the old saying. You learn your algebra in calculus, and you learn your calculus in differential equations. Raised to the 4th power. And of course, we can still continue on with this. dy over dx is equal to, and then we have a 2x minus 2 minus 3x, and that's going to simplify down to a negative x, negative 2, 3x, minus x, right? That's all over x minus 1 to the 4th. I think what I'm going to do now is I'm going to factor a negative out of here. So let's do that. Rewrite this thing one more time so we can start taking the second derivative. So I'm going to factor out a negative. So this becomes negative, and you know what? Yeah, I'm going to factor this negative out, but I'm going to also multiply this 3x across inside. So that's going to end up being 6x plus 3x squared, and that's all over x minus 1 to the 4th power. Okay, now what we're going to do is take the derivative again, right? Because we want to find the second derivative. I didn't say this problem was going to be easy. You know, the problem's not difficult, it just takes a while to do. Not a whole lot of thought behind it, actually. Okay, one thing is we got this negative out here in the front, and you got to really be careful about this because you could really mess some things up later on. So what I'm going to do is I'm going to just pull the negative out and just leave it here. Okay, and we're going to use the quotient rule on this. So that means we're going to take the derivative of the numerator, and by the way, I think I'll just box everything in. Right, we take the derivative of the numerator, so the derivative of 6x is 6, and the derivative of 3x squared is 6x, and we're going to multiply that by the denominator, the good old quotient rule, minus rewriting the numerator, and that is we need to put it in parentheses, times the derivative of the denominator. Now we take the 4 and bring it out front, and I don't know, I'll put the 4 right there in parentheses, and I gotta squeeze all this stuff in here. Alright, x minus 1, and of course subtracting 1 from 4 we get 3. Okay, and it's all over the denominator squared. So if that's raised to the 4th, right, I'm going to put a brackets around all this. Okay, and so that is squared, and of course we got brackets around the whole thing here. Got to be careful about these negatives. They will definitely get you. Well, you know what? I think I'm just going to leave it at that. Man. Well, what can I do here? Factor. I guess I am. I'm going to go ahead and. Okay, there's an x minus 1, an x minus 1 to the 4th, x minus 1 to the 3rd. So I'm going to pull out one of these. I'm going to pull out 3 of them, by the way. These x minus 1s. You always look at the one with the smallest exponent. That's the one we want to pull out. And I can actually pull a 6 out of here. But you know what? Let's just pull this out first. Man, all this pulling out stuff going on here. We got x minus 1 raised to the 3rd power. Okay, let's do that. I'll start another bracket here. I'm pulling, man, okay, 6 plus 6x, x minus 1. We're pulling 3 of them out, so we're only left with 1. Minus, so I'm going to go ahead and bring that 4 out front. And we got 6x plus 3x squared. No, pulled all 3 of those out. Yeah, okay. And we'll just do that. How's that? And that's all over x minus 1. Multiplying exponents, that would be 8. And now we can do some canceling here. Okay, we got a mess going on here. We're going to try to clean it up, though. Time to clean up the mess. We're almost done. We're getting there. What was this? D. I forgot what the heck I was doing. Taking the second derivative. That's what's going on. Alright, let's do some stuff. Let's see. Let's work on what's going on here. Or I don't know. Man, there's too much going on. I'm going to go ahead. Let's see. We got 3x minus 1s, and we got 8 of them down here. So I'm going to cancel 3 of them out, right? And let's just do that. And I think at the same time I'm going to do something else. Factor a 6 out. Let's do that. You know what? Let's not try to do it all at one time. Whoa. Need to do a brush stroke there. We got a 1 plus x and x minus 1. Let me just go ahead and distribute this across. So we're going to have 24x minus 12x squared. How's that? Work on a little bit of it at a time. And so I'm canceling 3 of these guys out down here, so that's going to make that an x minus 1 raised to the 5th power. Okay. I'm going to go ahead and multiply this 1 plus x and this x minus 1. So that's going to actually multiply to x squared minus 1. That would be the difference of 2 squares. Minus 24x minus 12x squared. So we're chipping away at this thing a little bit at a time. And let's see, we don't want to forget this negative now. It's still hanging around out here. Don't want to forget that. You gotta love these problems that are 10 minutes long. Of course, I'm trying not to skip any steps, so I'm going to go ahead and distribute this 6 across. So we have 6x squared minus 6 minus 24x minus 12x squared, and that's all over x minus 1 raised to the 5th power. Now it's time, tell you what it's time for. It's time to finish this problem. My goodness. Collecting up some like terms, we have a 6x squared, a minus 12x squared, and let's see here. Yeah, I'm ready to get this over with. I don't know about you. Minus 6 minus 24x minus 6x squared, right? You have a positive 6 minus 12, that's minus 6. We still got this negative hanging around out here. I promise we're going to do something with that eventually. Do something with something. Yeah, I think this is going to be the last step of this problem. Take it to the house. I'm going to factor a negative out right here. Let's do that. Factoring out a negative, we have a 6 plus 24x plus 6x squared x minus 1 all raised to the 5th. Well, I factored a negative out, but remember we still got this negative out here, and a negative is positive. So I'm not going to rewrite this problem. I'm going to say, okay, those guys cancel out. How's that? So there's your second derivative. It's 6 plus 24x plus 6x squared over x minus 1 raised to the 5th power. And we could actually factor a 6 out, but you know what? I'm done. Alright, let's work one that's got an exponential function involved in it. That would be e to the negative 3x. This looks like a good one. And we are asked to use some different notation here, the second derivative. So y prime is equal to, I like this notation a whole lot better. Y prime, so we're going to use the product rule here. So the derivative of x is 1. Rewriting e to the negative 3x plus, rewrite the first function, x times, and then the derivative of e, or negative 3x up here is negative 3. And then of course we rewrite the function. Okay, now let's rewrite this again. So we have e to the negative 3x. I'm going to bring this negative 3 out front, and e to the negative 3x. And what I'm going to do this time, excuse me, is I'm going to go ahead and factor out an e to the negative 3x, since we have one over here and then we have a separate one over here. So I'm going to factor that out, and so it's going to be left with 1 minus 3x. So you need to really get good at factoring things out. Now I'm going to use the product rule again, and this time we're finding the second derivative. So the derivative of e raised to negative 3x is negative 3. E to the negative 3x. If you're not sure how that works out, you need to go check the videos on finding the derivatives, or difference under differentiation, I think, and I worked quite a few of these exponential functions. Where are we at? Where are we? There we are. Plus e to the negative 3x, rewriting the first function, and the derivative of 1 minus 3x, and I'll put this in parentheses here, is negative 3. Right, so the derivative of 1 is 0, and derivative of negative 3x is just negative 3. And what's going on now? Let's do some factoring again. I'm going to factor out a negative 3e to the negative 3x, and that's going to be left with a 1 minus 3x plus 1. Okay, we had a negative 3x here and one over here, so we just pulled it out. Rewrite this one more time for you. We won't use square brackets, we'll just use parentheses, and so this becomes 2 minus 3x. And just check in, making sure everything's good, and I believe it is. So this is y double prime, also known as the second derivative. Alright. Let's move on to something bigger and better, maybe. Working higher order derivatives. Let's look at one's a natural log function. We got y is equal to ln of x plus 1 quantity squared, and we want to find the second derivative. Okay. So the first thing I'm going to do here is I'm going to, it is actually called the power rule, I believe, and we're not taking the derivative yet. Okay, we're just rewriting this thing, so it makes taking the derivative a whole lot easier. And that property is you can take this power and bring it out front and rewrite. So these are both equal. Now what I'm going to do is go ahead and take the derivative now. So the first derivative is 2 times, so you take the derivative of what's in parentheses, which is 1, and then you just rewrite what's in parentheses down here in the denominator. And of course we can rewrite this as 2 over x plus 1. Now we want to take the derivative again because we're finding the second derivative. But what I'm going to do here is You know what? I'll just go ahead and do the quotient rule. What's the derivative of the numerator? 0 times the denominator minus the numerator times the derivative of the denominator, and it's all over the denominator squared. Now we want to clean it up, so we say that the second derivative is equal to, so this is going to be 0 times, so this is all going to be 0 here, and we're just going to be left with a negative 2 up in the numerator, and it's all over x plus 1 quantity squared. Alright, so that's taking the second derivative there of that function. I hate it when it does that. Really what's going on here, the big picture is did it again. Oh, what is up, Nelly? Okay. The big picture here is we are basically reviewing on how to take derivatives. Let's do this one here. 2 raised to the 4x. See if you can remember how to do this. So we want to find the second derivative. So the first derivative is y prime is equal to, so you take the derivative of 4x, and that would just be 4. Rewrite. And then this time you take the natural log of whatever the base is here and bring it out. So this would be the natural log of 2. Put parentheses around that. And we're going to do this again. Y double prime. So we take the derivative of 4x and bring it out front. And that makes that a 16. Rewrite. Times, I'm rewriting this natural log of 2 here. Then remember we take the natural log of the base here, so that becomes the natural log of again of 2. Okay, but we can clean this up a little bit. So we have y double prime is equal to 16, and I'm going to join both these guys together, and natural log of 2, and then right there's 2 of them, they're multiplied, so that'd be quantity squared times 2 raised to the 4x. Alright, good enough. Alright, we are working higher order derivatives, and let's look at a log function this time. Let's say, and we'll use some different notation. Whoa, Nelly. Okay. Let's say we'll go back to f of x. How's that? F of x is equal to, how about log 3 times x? How about that one? Well, the first thing I'm going to do is I'm going to expand this before we even start taking the derivative. And by the way, I didn't state it, but we are finding f double prime of x here. So I'm going to first off expand this. This is all part of the log properties, and we can expand this guy right up to here. Okay, we got the product, we got 3 times x, we can expand that and make sure you put a plus. Only time this is a minus right here is if this were, for example, 3 over x, then we would put a minus. Alright, now what we want to do is take the derivative. So f prime of x. So log of 3 is just a number, okay? Constant, derivative constant, 0. Now we're taking the log of x over here, and you take the derivative of x, and that would be 1 over, and then you just rewrite whatever's in parentheses, except this time now in the denominator we are going to write the natural log of whatever the base is here, and if it's not written, anything's not written right here, then it's assumed to be a 10. So this is log with a base 10. Alright, that's the first derivative. Now let's look at the second derivative. So f double prime of x is equal to, and just for the heck of it, let's just use the quotient rule. So the derivative of the numerator is 0 times the denominator, and this is everything that's in the denominator, minus the numerator times the derivative of the denominator, and natural log of 10 is just a number. Okay, normally we'd just write that as a coefficient right over here, but it's written over here. But anyway, the derivative of x times natural log of 10 is just the natural log of 10, and of course it's all over the denominator, and this is going to be squared. Okay, let's clean this thing up. So we have f double prime of x is equal to, so 0 times this stuff here is a 0, and we're just going to be left with, it looks like a negative natural log of 10 up here in the numerator over, and we have x squared, and then we have the natural log of 10, and of course this is all quantity squared down here. Now we can reduce this down some more. So we have f double prime of x is equal to, now we have two natural log of 10s in the bottom, we have one in the top, so we can cancel one of those out. I'm going to throw that negative out here in the front, by the way. And so we're going to be left with x squared times the natural log of 10. Okay, I think that does that. Okay, so we're finished with that one, and I think I'm gonna have one more. We'll call it quits on finding higher order derivatives. Let me write my YouTube channel up here before we get started, where you can catch all my math videos. So youtube.com, and the keyword is heavy coin. Okay, let's get started here. We're finding higher order derivatives, and this is a tricky one here, and we want to find y double prime. So the first thing we're going to do is find y prime, and the way this works is I'm going to treat this like it's a number down here. Like for example, it's 2 raised to the x. So pretend this is a 2 raised to the x. So you got to remember how to take derivatives of these exponential functions, and so that we're going to take the derivative of x, and that derivative of x is 1, and then we just rewrite x raised to the x times the natural log of x. Okay, so it's the natural log of whatever this number is here, or the natural log of this. Okay, and then we say plus. Now we're going to treat this as though this was x raised to the 3rd power, like this is a number up here. So you would take that x and bring it out front, rewrite x raised to the x, but remember you subtract 1 from the exponent. Okay, we subtract 1. Now we can actually simplify this down. Let me just rewrite this. This is x raised to the x times the natural log of x plus, now this is a 1 right here. You add exponents. Our bases are the same, so we can add exponents. So this becomes a 1 plus x minus 1, so we're just left with an x raised to the x power. Now what I'm going to do next here is I'm going to factor out an x. So we're going to factor this x out, and we're left with the natural log of x plus 1, all in parentheses. Okay. Alright, And of course I'm going to need to rewrite this so we can remember what all that was. Okay, so this was x raised to the x and the natural log of x plus 1 close parentheses. Okay. Now we want to find the second derivative, and so remember what we use the product rule here, by the way. What's the derivative of x raised to the x? Well, isn't that just all of this? Right, so that's not confusing. The natural log of x plus 1. Okay, that's the derivative of this guy. Times, so we have to rewrite the second part of the function, the natural log of x plus 1. And of course I'm going to put a parentheses around this. And then this is going to be plus, now I'm about to run out of room here, but we rewrite the first function and we take the derivative of the natural log of x plus 1. Well, derivative of the natural log of x is just 1 over x. Alright, so now it's just a matter of cleaning it up. So this is going to be the second derivative. Now this guy right here is going to, we can rewrite that. And we have two of these, so I'm going to write this as the natural log of x plus 1 quantity squared, since there's two of them, plus x raised to the x minus 1, because when we take this up into the numerator and then add exponents, this is what we get. Well, you know what? I think I'm just going to leave it at that. So that's how you take the second derivative, and of course I've got lots of videos in calculus, and I'm uploading dozens every day to get you through your calculus class at youtube.com/heavycoin. Thank you.